Okay, my name is Theodore Skizao. I'm your physics teacher. Today we will see the last section of Unit 7. Last time we have seen about liquid and gaseous expansion. After that, expansion, after we finish expansion of liquid in the gases, we have seen about specific heat and heat capacity. Now today we'll see about change of state and latent heat capacity. Therefore, first let us see change of state. When we see change of state, when it says state or phase is a distinct form of substance under different conditions. For example, always one substance is either in solid, liquid or gaseous state, and these are the states. And there is a state change because of what? Heat. Therefore, to have a state change, heat is required. To change the state of a substance without change of temperature is known as latent heat. Latent heat. Therefore, we have two curves, the heating and the cooling curve. Let us see the heating curve first. The heating curve is a graph showing that the temperature of a substance against time as heat energy applied, and it changes state. It changes state. And for example, look at the graph below. Here this one is time and this one is temperature. And when the temperature rises, initially the substance is solid in this region. It's solid, and when it reaches the melting point, it melts and some becomes solid and some of them becomes liquid. After some time, that means after the temperature increase or moves above the melting point, the substance all in all changes to what? Liquid. And if the temperature rises again, when it reaches the boiling point, some of the liquid becomes in gaseous state and some of the liquid becomes in liquid state. And after some time, or after the temperature rises from the boiling point to some value increase, the whole liquid changes to what? Gaseous state. And this one is called the heating curve. And the second one is the cooling curve. The cooling curve is a graph showing that the temperature of a substance against time for heat energy loss, and this cooling is the loss of heat energy, but the heating curve is the gain or the increase in heat energy. Therefore, this in cooling curve there is loss of or decrease in heat energy, but in heating curve increase or gaining of heat energy. For example, let us see the graph shown below. This one is the cooling curve. Initially, the object is at high temperature, and at this temperature the substance is what? Gas. And if the temperature is dropped, when it reaches the boiling point, the substance is changed to, some of the substance is changed to liquid, and some of the substance becomes as it is, that is a gas. And when the temperature is again dropped below the boiling point, all the substance is changed to what? Liquid. And again, if the temperature starts decreasing to melting point, or when it reaches the melting point, all liquids are, or some of the liquids are changed to solid and some of the liquids becomes as it is. That means in this point we have both liquid and solid. And if it is temperature is decreased from the melting point, the substance all in all is changed to solid. And this one is called the cooling curve. In this cooling curve there is loss of energy, therefore the substance loses its heat energy. The other thing is specific latent heat. Specific latent heat is the quantity of heat energy required what? To change 1 kilogram of a substance from one state to another constant state. From one state to another state without what? Changing temperature. That means at constant temperature. Therefore, when a substance changes its state, there is no change in temperature. And a specific heat capacity is different from latent heat capacity. This specific latent heat capacity expresses about the quantity of heat energy, but both are expressed about the quantity of heat energy needed. But in this case, the specific latent heat is the amount or the quantity of heat energy required to change what? A state of matter. from one state to another state at constant temperature. We can express this mathematically. Specific latent heat is equal to energy required over mass energy required. And we can express this. L is equal to Q over M. This means heat energy required over mass energy required. And if you make crisscross, Q is equal to ml. L stands for specific latent heat and M stands for mass, and Q is the heat energy. The unit for this latent heat is joule per kilogram. And however, there are two changing state of matter, because a substance changes to liquid to gas and solid to liquid. Therefore, when a substance is changed to liquid to gas and solid to liquid, they have different latent heat. One is latent heat of melting, and the other is latent heat of boiling, or sometimes we named as latent heat of fusion and vaporization. Vaporization is when a substance is changed to liquid to gas, and fusion is solid to liquid. When it's melting. Latent heat of fusion is the amount of heat energy required to change a state of matter from solid to liquid. Therefore, latent heat of fusion is when a substance is changed to solid to liquid, and this happens at constant temperature. And latent heat of evaporation is the amount of heat energy required to change what? State from liquid to gas at a constant temperature. Specific latent heat of fusion, LF, is the amount of heat energy required to change 1 kilogram. If it is specific, it expresses the amount of mass. But if it is not specific, if it is generally latent heat, it cannot express the amount of the substance. Therefore, they have a difference between a specific latent heat of fusion and latent heat of fusion. Here, the amount of energy required to change a state of a substance from solid to liquid. The mass is not specified, but heat, here, if it is specific latent heat, it changes what? 1 kilogram of mass from solid to liquid at a constant temperature. To express this mathematically, LF, that means latent heat of fusion, specific latent heat of fusion, is equal to Q over M, and if you make crisscross, Q is equal to M times LF. LF stands for latent heat of fusion, and the second one is specific latent heat of vaporization. Since it says specific, here also, this is the amount of energy required to change 1 kilogram of substance from liquid to gaseous state at a constant temperature. We can express this also mathematically. And LV is equal to Q over M, and Q is equivalent to M times LV. We can use specific heat capacity and specific latent heat to calculate the total energy required when a substance are heated. Therefore, total energy required always when a substance is heated, total energy required is the energy required to increase in temperature, that is Q, which is equal to mc, change in T, and the energy required to change in state, that is Q, which is equal to ml. Therefore, Q total is always equivalent to mc, change in T, plus ml. This one is because of change in state, and this one is because of increase in temperature. Let us see one example. Here we are asked to calculate the amount of heat energy required to convert 200 grams of water at 100 degrees Celsius complete to steam, from water to steam, and the temperature is 100 degrees Celsius, and at 100 degrees Celsius there is no change in temperature, but there is what? Change in state. Therefore the givens are mass is 200 grams. This means in terms of kilogram, dividing by 1000, we can get 0.2 kilogram. And LV, that means latent heat of vaporization, because it's changed to steam. In other way, it is changed to gaseous state. Therefore, since it is liquid to gas, water is liquid, and steam is gas, therefore liquid to gas. Since it is liquid to gas, we can use latent heat of vaporization, and we can take this constant this constant, and we are asked to calculate Q. That means at this constant temperature, how much energy is required to change 200 grams of water at 100 degrees Celsius to steam at 100 degrees Celsius. To do this, we use Q is equivalent to mLV, and the mass is 0.2 kilogram, and latent heat of vaporization is 2.258 times 10 to the power of 6 joule per kilogram, and multiplying this, we can get how much? 4.516 times 10 to the power of 6, 10 to the power of 5 joule. Therefore, this amount of energy is required to change water to steam at 100 degrees Celsius. What amount? 200 grams of water. 200 grams of water. Let us take another example. How much energy is needed to how much energy is needed required increasing to change 200 grams of what? Ice at 0 degrees Celsius to 80 degrees Celsius of what? Water. As you see, initially the substance is what? Ice, and it's changed to water. Since it is changed to ice to water, there is change in the state, and the temperature is initially 0 degrees Celsius, and it's changed to 80 degrees Celsius. There is increase in temperature. Therefore, we have two values because of change in temperature, and the other one is because of increase in the first one is because of increase in temperature, and the second one is because of changing state. First, we have two states. The first one is the first stage is the increase in temperature. The second stage is the changing state. Therefore, let us do this. The heat energy required to melt the water. Therefore, that means Q1, that means to change ice to water, Q1 is equal to ml times fusion. Because it's solid to liquid, we can use latent heat of fusion. Therefore, we can substitute the mass is 0.2 kilogram. Since it is 200 gram, 200 gram is changed to kilogram. By dividing by 1000, you can get 0.2 kilogram times 3.366 times 10 to the power of 5. That is latent heat of vaporization, and the product of this gives us 6.67 times 10 to the power of 4 joule, or 66,720 joule. And this energy is the energy required to melt ice to, or to change ice to water. What amount? 200 gram. From 0 degrees Celsius to, no, there is no temperature, 200 gram of ice to what? Water. This amount of energy is required. And the second stage is there is increase in temperature from what? 0 to 80 degrees Celsius. Therefore, because of this increase in temperature, we have heat energy. That heat energy is Q2, MC change in T. That is because of change in temperature. 0.2 is the mass, and the specific capacity of water is 4,200 joule per kilogram degrees Celsius times 80 degrees Celsius. And the product of this all gives us 67,200 joule. And finally, the total energy required to change 0 degrees Celsius ice, 0 degrees Celsius ice to 80 degrees Celsius water is the sum of the two heat energies, Q1 plus Q2, and 66,720 joule plus 67,200 joule. This gives us finally 133,920 joule. And this is all about today. Until next time, have a nice time.